Hi, welcome. So we'll start things off. In this video, we are just going to set up a basic project with a basic window. We're just going to get things started. Just a note, I'm going to be going through in a higher level of detail in the early videos, just as we get things started. And then as our confidence grows, and I do mean we are in this together, then we will start to naturally pick the pace up a little bit. If you're already familiar with OpenGL, this might seem a little bit slow, but hopefully you can still get a bit of information from it. Otherwise, just feel free to skip ahead, I guess. But so here we are in our drive, and I like to make a folder called dev, where I just keep all my dev stuff. Doesn't matter. We'll just make a new folder. We'll call this, I don't know, OpenGL projects. That's fine. And this is where we're going to create our project. So what we'll need is we'll need Visual Studio, and it doesn't really matter which version we use. I like to use just the latest, but we can just go to Google and go Visual Studio download, just type that in. And here's a thing, and we can just download Community Edition, and that works just fine. It's free, it has everything that we need. Really, C++ options have gotten a lot better over the years. Code blocks, anything works. Okay, so that's fine. Let's say we've got Visual Studio. So we fire it up, and it gives us this welcome screen. We want to create a new project. Empty project, so we're going to go with. Let's just go back. This is one that I created ahead of time. Got to always be prepared. Okay, so we'll call this stage 1 window test. There. Okay, cool. So there are a few things that we need. The first thing we're going to need is a windowing library. Now there are a bunch of these. The two most common are Glfw and SDL. I'm going to go with Glfw for this video. It doesn't really matter. For our purposes, they're both approximately the same, just a few slight differences. In my experience, I found that Glfw was a little easier to get started. It doesn't really matter. Okay, so we just search for Glfw, and here's the website. We can go to download, and we can, if we want, download the source code and make it by hand. It's not super tricky, but I'm just going to grab 64-bit Windows binary. So we click that, and it just downloads the most recent version. Okay, cool. So we'll go to the downloads, and here we have it. And we'll just go, extract it. Now, there are two things which most C++ libraries have, which are really useful. There's a header file, which basically most of the time just has the declarations of the types of functions that you can call. And then we have the library file, which is most of the time the place where the actual definitions of those functions is. So we need both of those. We go to what we're using, Visual Studio 2019. Now this .dll is for once the program is fully compiled. We'll need access to that DLL. For now, the .lib is what we need. So we copy that, and then we'll go to our project. We'll make a new folder called Dependencies, and we'll paste this in, make a new folder called library, lib, paste that in. So there's two ways to work with this. One way is to have a common location on like C drive or D drive or something that all programs know about, and store our glfw there and link to that. And another option is to create a folder inside the project and link to that. Now that's good because we can set it up so that if we copy paste these files somewhere else, it will still keep the relative link. Okay, so what we also need is the include. So we go to include and we see this glfw, and inside we have the header files, glfw3.h, glfw3native.h. Okay, now let's grab that glfw and we'll just put this in dependencies just there. We just need it somewhere where we can link to it locally. Okay, so now here's a tricky part. I always found this kind of annoying. So we're going to set the program up so that it knows where these things are. First of all, see up the top we have x86. This is for 32-bit programs. I'm going to change that to 64-bit, x64. Okay, and then we'll go here to properties down the bottom. Now there's just one thing I missed as well. Where is it? Up here. On the Solution Explorer, it has this button, Show All Files. Note that we do not see the dependencies folder that we created because these are what's called filters or virtual folders. If we click this, it just shows the actual folders which are included in the directory. Okay, so we right-click and we go to Properties, and we make sure configuration, it doesn't matter. We just make sure that we are in 64-bit. Everything has to match up. And then down here, VC++ directories, we need to change our include directories. So we'll click in here and we'll make a new directory. And just so we can see this, we'll click macros and we have this macro called project directory, and we can see what it actually evaluates to. It evaluates to the relative path where our program is located. So we double click that, and that should be fine without a slash on the end, because we can see down here there is automatically a slash on the end added. So this is our includes. This is perfectly fine. We'll go OK, apply, that is good. Now we need to tell Visual Studio where our library is, which will pretty much be the same location. Oh, we won't do that. We'll go over to macros again. Project directories, and now we want project directories / lib. So remember, project directories automatically adds this /, we just put lib on the end. Now let's just double check that. We'll go edit again, and we'll click here, and we see it evaluates to our file path / lib, where we put the glfw3 lib. Okay, so now here's another confusing part. We also need to tell, let's just click in here. So we've got lib, and then inside lib, we've got this, wonder if I can, okay, there we go. Inside this lib, we've got this glfw3.lib, and we need to tell Visual Studio that we are interested in that specific file. So the way we do that is we go to linker and then input, and then here we have additional dependencies. See, it's got a bunch of .lib files already written in there. Okay, cool. So we go into there and we type glfw3.lib, and then we just double check. Yep, that matches. This is the thing that I hate most about this, because there's all these like random capitals and stuff. It's fine. Okay, so we click OK, apply, we are good. Okay, so let's go and add a new item, and we'll call this main.cpp. Okay. That's not a good sign. Ah, how did I miss this? Okay, sorry. So, of course, we want dependencies within there. And we want to do the same thing to the library. So, project, directories, dependencies, library. Okay, so this is a good sign because we see that we have glfw here, and then we want to include glfw3.h. Okay, awesome. So the next thing I'm going to do is I'm going to include iostream just so that I can get text out to the console, and then let's keep going. So we'll make a main function. The way functions work in C++ is we have the return type. So this is going to return an integer, a whole number, and then the name of the function. It doesn't take any inputs. Okay, so we call an initializer for glfw. And again, that doesn't take any inputs. And by the way, at the end of this, we want to return 0 to indicate that the program succeeded. So the next thing we're going to do is we're going to tell glfw what type of Opengl context we want to create. An Opengl context is basically a state machine that holds everything Opengl needs to make graphics. So we'll go glfw. We'll send a window hint, and we're going to okay, so there's a bunch of Opengl versions, and basically anything past 3.3 will work perfectly fine for this tutorial, but I want to have a bit of fun, so I'm going to use 4.5. That is, the major version is 4, the minor version is 5, 4.5. And there's another thing here, and that is the profile. So okay, so there are kind of two profiles to know about. One of them is core profile, which is pretty much the standard regular profile. The other one is immediate, which is like old legacy OpenGL. So when we go to draw something, the core version will send that instruction off to the GPU, and the GPU will take its own time on a separate thread, you know, to do its thing, to make the window, to draw the graphics. In core mode, the old way it was done is the CPU would be locked to the GPU. So we send a draw command, and the GPU does its thing, and while it does that, the main program waits. So as you can imagine, this slows things down, especially for more complicated graphics. Old OpenGL isn't that bad, but it's not the way we want to do things. So we've got this set up. Now what we need to do is create a window. So we have a function called Glfw create window. And what this does is it takes in a width of the window, height, a title, which is just a string. And then we have, if we're doing full screen, Glfw will want to know, well, which monitor do we want to display this on? Where do we want to be full screen? We don't want full screen. We're just going to have a windowed window. And then if we want another window to share resources or context with this window, then we can put in a pointer there. But we don't want to do any of that. Let's take this step by step. The width is 640. The height is 480. The title, let's just say, I hope this is working. Okay, monitor, we are not doing full screen, so we can just pass in null, which is a special code for nothing. And similarly, we are not sharing resources with another window. Okay, now what this does is it creates the window, allocates memory for it, and then it returns what's called a pointer or a memory location. And as we can see here, the type of pointer is a glfw window pointer. So what we do is we declare a variable, GL. Now the way this works is we have the data type and then this asterisk after that, in this situation, declares that that is a variable. Okay, cool. So now, if this fails, then it returns null. And the funny thing about null is null, as it says here, is defined as 0. So we can take advantage of that and say, if we don't have a window, in other words, if we have null or 0, then put out an error message. Failed, not gailed. There we have it. Okay, and then we're going to end the program, which is called by glfw terminate, return -1. That's a code to indicate that we failed. No problem. So then the next thing we need to do is we've got an Opengl context specified, but we need to make it current. And that's just as simple as passing in the pointer to the window, and glfw makes that window current. Now, there's another library that we need. So Opengl is pretty much a specification, kind of, and it's the responsibility of the driver manufacturers for the graphics card to implement the specification of Opengl. So you can imagine that Opengl pretty much doesn't know that much about where its functions have been implemented. So we need to do what's called loading a process address. So what that does is it queries on a system level where a certain function is on the system and returns a pointer to that function. Now this is a bit of work. We have a library called glad, which kind of automatically does this for us behind the scenes. So let's load that in. Okay, so we click search for glad download, and it's the first one here. Now the interesting thing about this is it generates these on the fly. So we want to work with C, C++. Yep. We want to use, in this case, Opengl 4.5 in core mode. Yep, that looks good. And then we have all these functions. We want to use all of these. So we click add all and then generate. So it generates these things on the fly. So we can click this glad.zip and it downloads it. Okay. Then we go to our downloads and we've got glad.zip right here. So we extract that. That's fine. And what do we have? Source src, we have this glad.c. So we actually need to grab that. No, Cortana, this is not the time. Okay. Now we'll put this actually in our project. So we'll paste that there where the rest is. Then we'll go to our dependencies. Then we have include. And in include, we have glad and khr. Let's grab both of those. KHR stands for Kronos, like Kronos Group, which is the group which initially created OpenGL. And still, I'm rambling. Anyway. Okay, so we've got this. Great. Now we need to include it. So first of all, we'll go to our project and we'll right-click and we'll say add existing item. And we'll add that glad.c, so that is in the project. Awesome. And then we need to go properties. Actually, I think we're fine because in the include directories, that's just pointing to dependencies, and glad and khr are folders within dependencies. So we should be fine. As a matter of fact, let's test it. So we'll go include. Yeah, we got glad and then glad.h. Awesome. So now we will continue. So we have this function, glad load GL loader. I wonder if this works. Okay, so it says here we need to pass in a glad load process, which is just any kind of general like function querying process. So we want to pass in glfw get process address. If we're using a different windowing library, we'll have a different default loader. SDL, for instance, has like an SDL get process address or something like that. And we get an error because this is not a glad load process. However, it's general enough that we can cast it to a glad load process. Oh, you just give me a second. I see what this is. This should be capital. Or should it? It should be a capital, and the other letters should not be capital. Good, we're working. Cool. So the way a cast works is in brackets we write the type that we want to cast it to, and then we write the thing that we want to cast. And this attempts to reinterpret the structure of a data type to match the general structure that we're looking for here. This casting with brackets is more of a C style of casting, but if we look here, we've got glad.c, so that kind of makes sense. Okay, so this returns 0 on failure. So we'll say if we got nothing, in other words, if we got 0 from here. So this kind of both calls the function and tests it at the same time. Then we'll put an error message. Keep writing Galed. I don't know why. It is what it is. Okay, so then we will also terminate. And return -1. However, having done that, we should now have access to pretty much all of OpenGL. So let's take advantage of that. Let's create a viewport. What do we have? We have x, y, width, and height. So we'll go 0, 0. Our width is 640. Our height is 480. We could be making variables for this, but it's perfectly fine. Awesome. And then let's create our main loop. So what this basically does is it just tests whether we've hit the X on our window. Yeah, it just tests whether we've hit the X on the window. Now what we can do is we'll go glfw swap buffers. Now this is using a double buffer render system where one buffer or a set of data pixels is being displayed on the screen, while at the same time there's another set in the background which is being drawn to in the current frame. There are reasons that we don't want the frame that we see right now to be currently drawn to. It creates synchronization issues or tearing where, you know, one part is being drawn while it's being displayed. It's bad. So it's common to have this system. We render to this frame and then we swap around. So the frame that we saw before is then redrawn over. Anyway, then the next thing we do is we call glfw poll events. I think we should really be doing this earlier. Now what this does, every time we move the mouse, click buttons and things, it creates glfw events, which are stored in a queue. And this queue starts to back up. So what poll events does is it flushes the queue basically to stop the queue of events, you know, backing up too much. So then the next thing we need to do is we need to, at the end our program. So typically at the end of a program, all of the memory which was allocated is freed up. So technically speaking, we don't need to call this at this point, or even at this point, or at this point. However, there's two things to bear in mind. Number one is as this program grows, this may become a smaller component of a larger program. If we have a game window and then a menu window and we want to create a new context for each one of them, then potentially this could create a memory leak if the memory is not being freed by glfw terminate. Uncommon. But then the second point is it's just good practice to get into the habit of working out where memory has been allocated behind the scenes and then making sure that we're freeing it up. We've got to be a good memory citizen. Okay, so this should be fine. We can run it. Oh no! So I was expecting this. This is fine. Okay, so it says we have an error. Let's look at the error. It says error, directive OpenGL header already included. Remove this include, glad already provides it. It says this happens in glad.h, line 641. Okay, let's go into dependencies. Okay, that's annoying. There should be a, yeah, hit refresh. Is that refresh? Sorry, okay, there we go. Dependencies, glad.h, and then we go down to line 641, and that is here. So this happens if gl.h has already been defined. Now let's think about this. What could be defining gl.h? Well, the only other thing we have that uses gl is glfw3, the windowing library. So maybe glfw3 is loading in OpenGL, and then glad is complaining because OpenGL is already loaded, which seems like a strange thing to complain about, but let's try this. Let's try including glad first, and then glfw3. And now it works. I hope this is working. As a matter of fact, it is working. Okay, cool. So, and we have that. Oh no. Guys, I'm sorry. I just realized this text is way too small to be like practically readable, and that's way too big. So let's go with, actually, I might be able to make this work. That's a little better. Okay, so apologies if I've been doing this whole tutorial with the text too small. Let's just go with it now. It's going to be good now. Okay, so to recap, we initialize glfw, we set up the context, and then we create a window. We call glad gl loader to get all of the function pointers for OpenGL. And yeah, okay, so there's one more thing that I want to do, and that is let's create a general function to handle like mouse presses and things. So what we'll do here is we'll make a function. This function will not return anything. We take in a window pointer and let's see. Okay, cool. So what we're doing is we're looking for the escape key and we're testing if it has been pressed. This gets the state of the key. Okay, cool. So if that happens, let's set it so that we exit. So we'll say glw. Okay, and that's it. That's our function. So let's test it. We run, we've got a window, we hit escape. We hit escape. Oi. Of course, right? We need to actually call that. So we go down here and we say, yeah, call the process input function. Okay. Oh yeah, of course. What am I thinking? We need to pass in the window. Okay, so we run this. We hit escape, it exits. Awesome. Okay, so that'll be it for now. Hope you had fun. Apologies for the text issue. It's fixed now and it will be big and visible in future videos. And yeah, have fun. See you in the next one.